Uh, this is Priyanka, Assistant Professor, Department of CSC. Today we are going to see the basic concepts of semiconductor RAM. First of all, we move for what is a random access memory. It's a crucial hardware component in any modern computer or digital device. This is show the RAM modules, often called RAM sticks. Okay, what is RAM? Random stands for a random access memory. It's a type of volatile memory, meaning it only stores data temporarily while the computer is powered on. When the system is turned off, all data in RAM is lost. Why we want to use this? RAM acts as a workspace of the computer. It stores the data and instruction that the CPU, that is a central processing unit, needs right now. This makes accessing information extremely fast compared to the storing it on a hard disk or SSD. The importance of RAM is speed, multitasking, loading program, and also some types of RAMs are there: DRAM, SRAM, DDR. Some key features is volatile, fast, read, and temporary storage, essential for running programs successfully. These are the things occurs in basic concept, basic RAM. Okay, then we see the random access. Random access allows the computer to access any byte of data directly and instantly. This means no matter where the data is physically located in memory, it takes the same amount of time to reach it. We do that, it occurs faster and more efficient processing. Then is a volatility. RAM is a volatile, meaning it needs a continuous power supply to keep the stored data. If the computer shut down or there is a power cut, all data in RAM is lost. RAM cannot be used for long-term storage. Performance, modern RAM data have very high transfer speed. For example, DDR4 can reach up to 25.6 GB, allowing rapid reading or writing of data. It results occurs faster loading, smoother multitasking, and better overall system performance. The capacity of RAM is measured in gigabytes. Common size include 8 GB, 16 GB, 32 GB. More RAM allows applications to run simultaneously without slowing down. Better multitasking and smoother performance in heavy tasks. Example, gaming, editing, etc. These are the key characteristics occurs in RAM. Then we see the block diagram. A functional block, a semiconductor memory like RAM or ROM, stores data in organized array of cells. This includes how data is addressed, accessed, stored, and retained. First, address line. The CPU sends an n-bit address to specify where data should be read from or written to a qubit or bit. Qubit is nothing but the row decoder. Orbit is nothing but the column decoder. Row decoder is nothing but it takes in q inputs from the address. Activate one of the 2 power q rows in the memory array. It selects the horizontal row where the data resides. Column decoder is nothing but it takes all inputs from the bit address. Activate one of the 2 power or columns in the memory array. It selects the vertical column of the data. Okay. Then what is a memory array? The heat of the memory. It contains a 2 power n storage locations, each storing m bit. That is, m is equal to word length. Example, one word is equal to 8 bit, 16 bit, etc. The selected row plus column combination uniquely identifies one memory cells. Okay, then move for an input buffer. Input buffer is used when writing the data into memory. Ensure stable and clean data signals before they are written in the selected memory cells. Output buffer is nothing but it used during reading data from memory. It amplifies and stabilizes the signal before sending into external M data lines. Then what is data lines? It carries the data to or from the memory. For example, if M is equal to 8-bit data bus is used. Okay. These are the things occurs in the block diagram. Next we move for a static RAM. Static RAM structure, it stores each bit of data using 6 transistors arranged in a flip-flop circuit. A flip-flop is a small digital circuit that can hold either as 0 or 1 as long as power is supplied. Because of this transistor-based design, SRAM is more complex but also more stable. What is the mechanism? Unlike DRAM, which needs constant refreshing, SRAM stores data statistically. Once a bit is set, it stays the same without periodic refresh as long as electricity is flowing. This makes SRAM faster and simpler in operation. Okay, what are the advantages? Very fast access time, typically 1 to 10 nanoseconds, low standby power consumption, since it does not need any refresh cycles, consistent performance because the access time is stable. Some disadvantages also there. Higher cost per bit because 6 transistors per bit takes more chip area. Lower density, it means you can store less data in the same space compared to the DRAM. Higher active power consumption since more transistors switch during operation. Okay, what are the applications are there? L1 cache, L2 cache, L3 cache. Typical cache size ranges from 256 KB to 32 MP depending on the processor design. Next, we move for dynamic RAM. Here we see the structure, mechanism, advantage, disadvantage, applications based on the SRAM. Difference between the SRAM and VRAM. SRAM is a low storage capacity because each bit requires 6 transistors. This makes it bulkier, so fewer bits can fit on a single chip. DRAM is a dynamic RAM. It has a large storage capacity because each bit is stored using one transistor, one capacitor. This allows many more bits to fit in the same area. It is a low density and it's a high density. That is, low density means fewer can fabricate in a given area. High density means more power, more memory per chip. The usage of this SRAM is used in cache memory. Here used in main memory. Then cost is more expensive. Here DRAM is cheaper, requires few components per bit, making it cost efficient. These are the things of difference of SRAM and VRAM. Thank you.